So in this video, I'm going to do 5 examples of adding and subtracting fractions, and sometimes those subtraction will involve borrowing. This first one, we already have common denominators, so negative 2 and 1/3 plus negative 1 and 2/3 is what we are evaluating. If you ever have a sentence that says find the sum of, or one that says find the difference of, however these two numbers are listed, that's the order that they have to stay in your math sentence. Just keep that in mind. So we should know that negative 2 and negative 1 can just be added. We can come over here to our little t-chart and say, okay, this is not in the positive side, goes in the negative side. That one also goes in the negative side. So I know I'm just going to get to add those. 2 plus 1 is 3. Again, 1 plus 2 is 3. So I get 3 and 3/3. This answer is not in simplest form because 3/3 is another whole. So the answer to this question is actually 4. And then we need to make sure we go back and assign the value if it's negative or positive. So the sum of negative 2 and 1/3 and negative 1 and 2/3 is negative 4. Over here on this one, we need to find a common denominator. Again, it's not that super important if we find the least common denominator, but in this case, I'm going to leave 8/15 alone because I instantly can tell that I can get this 3 to become a 15. So I'm going to multiply this by 5 and multiply this by 5. Remember, you are indeed multiplying 2/3 times 5/5 to get it to where it's 2 times 5, which is 10, 3 times 5, which is 15. So be super careful with that. I see some students writing it differently, and just know that you're not just multiplying by 5, you're multiplying by 5/5, which is really just multiplying by 1. So it didn't change the identity of the fraction. So now we have the 10/15. So notice I've put these over here without a sign in between them yet, because I want to do LCA. Leave 8/15 the same. Change this subtraction symbol right here to an addition symbol. And then what is the additive inverse of negative 2/3? The additive inverse of negative 2/3 is positive 2/3, which we now know that positive 2/3 is equivalent to 10/15. So 8 plus 10 is 18/15. Remember, we do add the numerators, but we do not add the denominators because we want our answer to be out of 15 pieces. We don't add the denominators. We're adding that we got 8 out of 15 pieces in this cake, 10 out of 15 pieces in this cake. So that means we have 18 out of 15, or we have one whole cake with 3 pieces left over out of 15, which equals one whole cake and 1 out of 5. If the cake were cut into 5 pieces, you would get one big slice for this one. So that's the answer there. So this leads us to this guy. Again, we need to find a common denominator. I'm just going to kind of be lazier with this one and not even try to figure out the least common one, but I think by doing this you will. 2 times 15 is what? It is 30. Right? So what did I multiply to get this to be 30? I did 2 times 15. So I'm going to multiply this by 15 as well and get 15 out of 30. Negative 2 and 15/30. Here, I multiply by 2. So I'm going to multiply this by 2 and get negative 8/30 minus 5 and 8/30. Since this is involving negatives, I'm going to do LCA again to this new question. LCA. So I'm going to leave this guy alone, negative 2 and 15/30. I'm going to change this subtraction sign to addition, and I'm going to change this negative 5 and 8/30, this positive 5 and 8/30 to negative 5 and 8/30. So here we go. Now we could try to use the T-chart again. At this point, hopefully we can kind of do it without it. -2 plus -5 is -7. 15 plus 8 is 23. And then the denominator stays the same. And since 23 is a prime number, this can't be simplified. We could try some of our divisibility rules on it. 2 plus 3 is 5, which isn't divisible by 3, and then, so that means 6, and so it's just, that's already in simplest form. So let's do this one more problem before I erase. So the first time I tried to do this page down there, I just kind of ran out of room to show you the 3 different strategies. So that's how it's moved up here miraculously. So I'm going to change this into 5 and 4/8 minus 3 and 7/8. If you take a second to analyze this question, you can see that the 4 in this question is smaller than the 7 here, which is going to lead into a problem as you evaluate this. So if we just try to just go into this, let's evaluate it. 5 minus 3 is 2. 4 minus 7 is -3 over 8. So the 2 was positive, but the fraction is negative. So really, this means 2 minus 3/8. So I need to change this guy right here to a mixed number and make him be 1 and 8/8. So how did I get 8/8? Well, it's 1 plus 1, 2. Yes. I know that I want the fraction to have a denominator of 8, and I know that 8 over 8 is equal to 1. So that's where that came from. So now I'm going to subtract 3/8, and I get 1 and 5/8. Another thing that you could have done at this point, instead of changing it to this mixed number, is you could have changed it to 16 over 8. So now you might be asking yourself, where did 16 come from? So 2 over 1 is 2. That's 2 written as a fraction, right? So if I take that and multiply it by 8 and multiply this by 8, I get that 2 is equivalent to 16 divided by 8. 16/8. Is that indeed true? 16 divided by 8, does it lead me back to 2 again? So now what I have is 16 minus 3 is 15 over 8. And does 15 over 8 change to 1 and 5/8 whenever I change it from an improper fraction to a mixed number? It does. So I want to show you guys another approach to this question. Same question, different approach. I just showed you guys 2 approaches to it, so you can kind of choose the one you like. So again, here I have 5 and 4/8 minus 3 and 7/8. This guy is coming up short. So I'm going to borrow from this 5. What I'm borrowing from the 5 is a group of 1. But that group of 1 is made out of 8 pieces out of 8 pieces. That's the concept that you need to understand, is we're taking 8 pieces. We're taking one of those cakes and breaking it up into 8 pieces. So that leaves me 4 entire cakes, and then an 8 out of 8 cake, plus the 4 out of 8 cake I already had there. So that gives me how many pieces of cake now? 8 plus 4 is 8, 9, 10, 11, 12. So I get 4 and 12/8 minus 3 and 7/8. So what I did is I basically took one of the ones out and made it kind of be like 1 and 4/8 if you want another way to look at it. I just took a 1 out. 8 times 1 is 8 plus 4 is 12/8. Is another way that 12/8 came into play. So 4 minus 3 is again 1, and 12 minus 7 is 5, and then that is 5/8. So again, that's another way to have done this question. So the last way I'm going to show you guys to do it just involves, first let's find common denominator. So we know that this is 5 and 4/8. And then let's just change them both to improper fractions. 5 times 8 is 40, so that's 44 over 8. 3 times 8 is 24. 24, 25, 26, 27, 28, 29, 30, 31. So that's 31 over 8. And 44 minus 31 gives me, that's a what? What is that? That's 3. And that's a 1. So that gives me that 13 over 8, which is equal to 1 and 5/8. So that's a bunch of different strategies for doing subtraction involving borrowing. So let's this guy over here. Let's find the common denominator. I get 5 and 4/6 minus 6 and 5/6. We should automatically know that this is going to be a negative number. But to me, the easiest way to do this one is let's just go straight to changing it into an improper fraction. 6 times 5 is 30 plus 4 is 34 over 6. 6 times 6 is 36 plus 5 is 41 over 6. So I'm kind of stuck here to where it's still going to end up negative, but you guys should know you can either do LCA, leave, change, additive inverse. Now the only things that have to go in our T-chart are the 34 is positive, the 41 is negative, so we know we're going to subtract those. We have to do all this borrowing. 4 to 11, so I can count that out. Let's 4, 5, 6, 7, 8, 9, 10, 11. So that's 1, 2, 3, 4, 5, 6, 7. And the 3's cancel. So this is 7/6. So that means it's 1 and 1/6, and that it's negative. So I just kind of skipped over a lot of the other strategies for that one. Does anyone have any questions? If you do, try to replay this, or you guys can send me a message or make a comment, and I'll try to answer it. Thank you.